Cassidy, what's an earthquake? Okay, why does it shake?
Ooh, I know this one.
Drake? Why does it make an earthquake?
Yeah.
So why does it make an earthquake?
Because of friction. Makes it shake.
Do the plates constantly, I guess, how should I put this? Incessantly, you guys know what that means? Non-stop. Are the plates always grinding against one another?
No.
Are they always in constant movement? So then what creates the earthquake? What happened? Okay, if they're not sliding past one another, then what's happening? They're colliding. Are they colliding smoothly?
No.
So what's happening? Okay. Tanner?
They're like crumbling into each other.
Like, kind of. Kind of. And we think about earthquakes, I know we think about plate tectonics. The thing is with plate tectonics, it's regional. It's on a massive scale, right? But our earthquakes aren't always on a massive scale. They're usually a single earthquake that occurs. Now, usually you can piece out the earthquakes and actually follow fault lines. And the fault lines are results of plate tectonics. So again, what we're talking about today are going to be very small local regions. Okay, they're not very large regions at all. They're very small, very local. Okay. Now let's think about these two blocks of land. What's happening right now? Okay. Well, what's happening there at the top? They're uneven. Okay. What just happened there? Okay. Why did it shoot it? So that's not sliding past here. What's happening with that two pieces of land? You guys see that? What's happening there? I was like, come on. What's happening? Okay, so they're getting stuck. Okay. Well, our crust does the same thing. As two blocks of land, not necessarily plates, but two blocks of land are moving past one another, whether one's being subducted underneath the other, or they're literally sliding past one another. What's happening is they get stuck. There's friction. And the rocks get stuck underneath one another. Well, what happens is you get stuck, and the rocks will move and they'll bend with that pressure. But eventually, what happens? It snaps. There's so much pressure and force pushing those two blocks of land that eventually it gives way. And when it gives way, just so you guys saw there, it juts. That's the earthquake. It's when that sudden jut of that block of land very quickly moves and it releases a lot of energy, and that's what an earthquake is. Make sure you guys write that down. So an earthquake is basically the sudden release of energy from between two blocks of land. As we saw before, when these two blocks of land are rubbing up against each other, right, they're creating something called stress. How many of you guys felt stress this weekend on your holiday break? I was having a good Sunday until about 8:30, and then my Sunday went down.
Why?
Not a good day for the Tigers. Alright, so with the stress, we actually get a lot of bending. In fact, if you kind of watch this piece of land right here, and even though it is just made out of cardboard, it's a perfect example of this. As this piece grinds up against it, what starts to happen to that piece of cardboard? It starts to lift up. So we're getting that's part of the stress that's occurring. And it's deformation. To deform something, it's deformation. And basically it's lifting that, it's going to bend it, it'll twist it. And so we get all these really interesting types of folds that occur when we have these stresses. So the stress, if you want to think about it, is a force exerted on the rocks. Okay, that's a good way of looking at stress. It's some force exerted. What does it mean to be exerted? When I say force exerted on the rocks, what does that mean? Yeah, it's applied. Okay, so it's the force that's being applied to the rocks. Excuse me. And we have 3 types of stresses. And each one of these stresses is uniquely tied to a special type of force. So let's first take a look at compression. What does it mean to compress something? Say it again? Push it together. So if I have a single block of land, and I start compressing this, what happens to the rock?
It's smaller.
Okay, so it gets thinner, right? So we get a horizontal shortening. Well, what happens to my vertical? It's getting taller, right? So we're getting squished. So we get, and this is what I want you guys to write, we're getting horizontal shortening, and we're getting a vertical stretch. Okay, so that's compression.
Horizontal what?
Horizontal shortening, right? Pushing it in. We're getting a vertical stretch. So that's with compression, what's being pushed together. If we have tension, someone talk to me. Where have you heard this tension word before? Specifically in science. Where have we heard about tension? Not electricity. You guys ever heard of this? Tensile strength? Have you heard of that? Really? Never heard about tension forces? Okay. Describe it to me.
Pressure between 2 objects.
It's not necessarily between 2 objects. There we go. So when you're pulling something apart, okay, take a rope, and if you pull the rope, that's a tension force. Okay, so anytime you're having something that's being pulled in 2 opposite directions, that's a tension force. When we talk about tensile strength, one of the things that they do when they test particular products, like I said, over the summer I visited this the Nucor fastener plant out in St. Joe, and what they do is they do these random testings out of their batches, and so they take these gigantic bolts that they create, and some of these bolts are for very important projects, like Mackinac Bridge would be one of them. They do them for a lot of the bridges all around the nation, the Golden State Bridge, right? So all these things are kind of important that these bolts hold their strength. Okay, some of them get used for a lot of our aircraft carriers and a lot of our battleships. So it's important that these bolts actually do what they're designed to do and hold against strength. So what they have to do, they test these. And they put it in this machine that literally starts to pull the bolts. So they lock it in place, and then the machine slowly pulls at the bolt. And then what you start to see is it starts to stretch. Well, what happens to the center? It gets thinner, right? So imagine pulling this block of land, and what happens to my middle? It gets really thin in the middle, okay? Same thing with that bolt. It'll get really, really thin in that middle. And eventually, the bolt eventually just snaps. Okay, when it snaps, it's very loud. But this is kind of a perfect example when we talk about tension. So what's happening with tension is you're pulling this block of land apart. So remember we talked about rift valleys. All right, we talked about those being on land, right? That's a divergent plate boundary. So with a rift valley, it's the same thing taking place. You're taking these large blocks of land, and you're literally pulling them apart. And as you pull them apart, what happens to the middle piece? falls down, right? It thins out and falls down. Okay, so that's basically a perfect example of tension. So we have a horizontal stretch, but a vertical shortening. Okay, so tension is basically the complete opposite of compression. All right, this up. Okay, the next one I want to talk about is called the shear stress. Where have you guys heard that term before? Shear. You guys heard that before? Shear? Okay. Kind of slows it down. And the diagram I have for shear, it's really hard to understand what's going on with this diagram. What's happening is you have two forces acting in opposite direction, similar to tension. Except for tension is pulling it apart. What's happening in shear is the two forces are literally going in this direction. You got one coming in this direction, one going in that direction, and it's literally ripping the land. So you get this shear. Okay, it's thinking about like shear winds, right? Really ripping it and pulling it in two opposite directions. And so you can kind of see that in this diagram here, where the two arrows, one's pushing this block going in that direction, this one's pushing in this direction. So those are your forces and types of stress. All right, any question on those types of stresses before we move forward? True or false? Rocks are bendable.
True.
True, right? With enough heat and enough pressure, the rocks will bend. Okay. True or false? A wood board is pliable. A wooden board is pliable. And what does pliable mean? It means to be able to bend. Okay? Does wood bend?
No. Breaks and